what will happen? How will the final velocities compare when the two balls reach the ground? So to help us think about this question, maybe we should draw a picture. So we have a building, and we throw these two balls. One is thrown with an upward speed of v0, and the other one is thrown with a downward speed of v0. And we want to know what's going to happen when those two balls reach the ground. So maybe I should have drawn my picture a bit lower, like this, so I can think about the whole arc of the ball. v0, v0. So what's going to happen to this upward thrown ball? Well, the upward thrown ball is going to move upwards. It's going to slow down and slow and slow and slow until at the top of the arc it briefly goes to 0, just for an instant, and then the ball is going to come back down, 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 to where it's at the level, or the same level as the top of the building. What's the velocity of the ball going to be at this point? What will its velocity be after it goes up and after it comes back down again? Well, this motion is somewhat symmetric. It spends the same amount of time slowing down as it does speeding up, and the acceleration is always constant. We could think about this in terms of our free fall equations as well. One of our free fall equations says that delta y is equal to v0 squared minus v squared over 2g. Now at this point, the change in height is 0. When the ball goes up and comes back down, it's at the same height as it was before. So the final height minus the initial height is 0. So our delta y is 0 at this point. So if 0 is equal to the initial speed squared minus the final speed squared over 2g, if I multiply both sides by 2g times 0 is, of course, still 0. And so 0 is equal to v0 squared minus v squared, or v squared is equal to v0 squared. So that means that the velocity here, at this point, when the ball comes back down, will also be equal to v0. So it loses a bunch of speed, but then it regains that speed as the ball falls downward. So at this point, the ball that has gone up and then come back down will have the speed v0, just like the downward thrown ball. So at this point in the motion, it's in the same situation as the downward thrown ball, and the motion from this point downward will be the same for both balls. And so right before both balls touch the ground, they will be moving with the same speed. So the velocities of both balls would be equal.